I have a sample problem up here on the board. As we start this next unit, what we're going to be looking at for the next couple of weeks are going to be more complex applications of trigonometry. And in these problems, just like some of the ones at the end of the last unit, the big issue is going to be finding the right triangles or finding any triangle in which for us to apply our trig concepts to. So for this one here, there are two things that we're going to be asked to find. I'm going to ask you to find the distance x, which is going to be the length of this tangent line between the two circles. We're going to find that length x. The second thing we're going to find is the area of this whole figure enclosed by this whole outline here. So let's start off by just dividing this thing up into shapes to where we can get a right triangle. Now, the first step is to find right angles. Now, we've said that there are two main strategies for finding right angles. One of them is looking for horizontal and vertical lines where they intersect. We don't really have that here. The second one was a radius of a circle to a point of tangency. And we actually have two of those here. Actually, four of them if we wanted to look on top. But we have the radius of that circle to that point of tangency. That'll form a right angle. And the radius of this circle to that point of tangency, which will form a right angle. Now, a kind of a common sense geometric rule, but one that kind of fits in with things that we've learned as well, is anytime we have lines that are perpendicular to the same line, like this one and this one, they have to be parallel to each other. So those two lines are parallel. We're going to construct another line that is parallel to this tangent down here. And we're going to do it in such a way, we're going to start with the circle that has the smallest radius, this one here, and we're going to come parallel to that tangent like that. So those are also right angles. So what we have formed down here is a rectangle. That rectangle has known dimension, well, one of the dimensions known at least. This one right here is just the radius of this circle. So half of the 0.9 is going to be 0.45 inches, will be that radius. Over here, we actually do have one side that is known. This side right here is known to be the difference between this radius and this radius here. So the radius of the big circle is 0.7 minus the radius of the little circle of 0.45. That gives us 0.25 inches is that length. Next, if I connect the centers of those two circles, this here is still a right angle because we have this green line intersects at a right angle. It's a right angle on both sides. That blue line connecting the centers is what's given down here is 1.2 inches. So what we have here is a triangle, this one right here, the right triangle, where we know that this is 1.2 inches and this is 0.25 inches. We need to find this third side down here. This is actually x. Well, we know that x squared plus 0.25 squared has to add up to 1.2 squared. That's just our Pythagorean theorem. So we're going to solve that. X is going to equal the square root of 1.2 squared minus 0.25 squared. Now, I skipped a lot of steps in solving that. I just rearranged this formula up here to solve for x. That's going to give us that x is 1.174 inches. That's our answer for x. Find the area. Well, we have a couple of shapes that we know here. Let's start off with this triangle right here. Find the area of that triangle. This is 1.174. The area of that triangle, which I'm going to label piece 1, is just 1.174 inches times 0.25 inches divided by 2. Now, there are going to be 2 of those triangles. If we look at this very closely, you'll see there's going to be this exact same triangle up here. So I'm going to multiply that times 2 as well. So 1.174 times 0.25. Now, dividing by 2 and then multiplying by 2 are going to cancel out. So I'm just going to multiply it out. I get 0.2935 inches squared. So that is both this triangle and this triangle. Next, my second piece I'm going to do is going to be this rectangle, which of course is the same as this one up here. That one's going to be 0.45 times our x that turns out to be 1.174. Again, there's going to be 2 of those, so that'll be times 2 as well. 0.45 times 1.174 times 2 gives us 1.056. 1.0566 actually, square inches. So that's this rectangle and this rectangle. So now what we have left is this sector of a circle. Here, it's going to be slightly larger than half the circle. And this sector of a circle here, excuse me, that's slightly less than half the circle. To find either of those, we need to know this angle and that angle. And the key to finding either of those angles is this angle over here in our triangle. Now, I'm going to go back to information that we found by just subtracting rather than using this one here, because we know this one is rounded, because we had to do the square root and round it off. So I'm going to use this side, which is the opposite side according to that angle, and this side, which is the hypotenuse. Well, opposite and hypotenuse are sine. So I'm going to call that angle angle A. So sine of A is opposite over hypotenuse. So sine of A is 0.25 over 1.2, which is telling us that angle A is the inverse sine of 0.25 over 1.2. Yes. Well, let's get my mode set again. (12.02 degrees). What does that tell us? Well, it tells us that if we're looking at this piece right here, that circle, we have this angle that's 12.02 degrees. This angle here that's also 12.02 degrees. And then we have these 2 right angles, which of course are 90 degrees each. If I add those 4 angles up, I get a total angle here of 204.04 degrees. That angle is actually going to be this one right here. This one over here is going to be the supplement of that. 108, or not the supplement, it's going to be actually 360 minus the 204.04 degrees. So it's not the supplement, it's the difference from a full angle, from a full rotation. So this is going to be 155.96 degrees here. So we need to find those two sector areas. I will start with this one over here. This will be my piece 3. Piece 3 has a radius of 0.7, so that's pi times 0.7 squared. That would be the full circle, times that central angle of 204.04 degrees over 360. 3.14 times 0.7 squared is 204.04 divided by 360. I get that sector area of 0.8720 inches squared. And then for this piece, which I'll call piece 4, that'll be pi times, that radius is 0.45 inches, so pi times 0.45 squared, that would be the whole circle, times my 155.96 degrees over 360. 3.14 times 0.45 squared, 155.96 divided by 360. 0.2755 inches squared. Now we need to add all these up here. Being 2.4976 square inches is my area. If I added those all correctly, which I think I did. There we are. Not so bad. Better than a sharp stick in the eye? So far, right? Our next example is going to be kind of a Quonset hut type example. This actually happens a lot if you have a shaft, for like a cam shaft and stuff like that, where you need to have indicator knobs or other activation points on a shaft. So we're actually going to be looking at a half shaft today, just to simplify the calculation a little bit. We're going to pretend that that looks like half a circle. And this is going to be half a circle, radius of 30 millimeters. And we're going to come out here. This is going to be a right angle, of course. We're going to get a height of 10 millimeters here, and we're going to bring this in here, tangent to the circle. But that line is going to have a 1:3 aspect ratio. So that means it rises 1 unit for every 3 units it goes over. Once again, there's going to be 2 things we're asked to find here. We're going to be asked to find the distance x, and we're also, again, going to be asked to find the area of this. Well, to find our distance x, we need to find some angles. Obviously, I can draw in my radius to the tangent here. That's going to be a right angle. Unfortunately, that right angle doesn't do much for us because I don't know this angle down here. So what we're going to do is this. I'm going to find this angle here. I'm going to call that angle A for right now. Angle A comes from this aspect ratio. If I flip that over and set it like this side of the triangle has 1 unit, this side of the triangle is 3 units. That is angle A. So according to that angle, 1 is the opposite side and 3 is the adjacent side. Dealing with opposite and adjacent is tangent. Tangent of an angle is opposite over adjacent. So I'll put angle A in there for my angle, my 1 for my opposite side, 3 for my adjacent side. And since I am looking for the angle, I use an inverse trig function. Angle A is the inverse tangent of 1 over 3. Giving us 18.43 degrees. We also know, by the way, that this is a right angle here because we cut that off to be horizontal. That aspect ratio is comparing horizontal to vertical, so this line here has to be horizontal. I'm going to extend this over until I get to this point here. I'm going to drop this point straight down to make a right angle here. I'm going to extend this straight over to make 2 more right angles there and there. So this is a rectangle. This is a right triangle, and this is a right triangle. I know that this has to be 10 millimeters because the other side of that rectangle is also 10 millimeters. I know that this side here is 30 millimeters because that is still a radius of that circle. Now here's the tricky part. I know this angle right here is 71.57 degrees because it's part of this triangle here, and I know 2 of the angles in that triangle. I know the 18.43 and I know the right angle. So subtracting from 180 gives me that 71.57. Which means this angle right here is 18.43 degrees. Because this was a right angle up here. When I subtract the 71.57 from that 90, I am left with the 18.43 degrees. It really makes sense. This should be the same distance from vertical as this is from horizontal, because they form that right angle up here. So let's look at that triangle a little bit more detail here. This is 18.43 degrees. This is 30 millimeters. I'm going to find both of these other sides. I'm going to call this side here side B, and this side D over here. According to this angle, B would be the opposite side. Our 30, of course, is our hypotenuse. The opposite and hypotenuse is sine. So it's the sine of 18.43 degrees equals that opposite side B over my hypotenuse of 30. I'll put that over 1 so that I can cross multiply and divide. The sine of 18.43 times 30 divided by 1 is 9.48. So B down here is 9.48 millimeters. I'm going to go up and label that on my main drawing here. Next, I can find side D. Side D would be the adjacent side to my 18.43 degree angle. Adjacent and hypotenuse would be cosine. Cosine of theta is the adjacent side over the hypotenuse. So the cosine of 18.43 degrees equals D over 30. So once again, I put that over 1 so that I can cross multiply and divide. So the cosine of 18.43, close that parentheses, times 30 and divided by 1 is 28.46. This is 28.46 millimeters. Go back up to my drawing and put that in. So from here to here is 28.46 millimeters. That means that from here to there is 28.46 minus 10, or 18.46 millimeters. Now we can explore this triangle more. I know this is 18.46 millimeters. There's my right angle, and this one is 18.43 degrees. All I really need to know here is this bottom side here, which I'm going to call F. So 18.46 is the opposite side. F is the adjacent side. I am dealing with a tangent. Tangent of an angle is the length of the opposite side divided by the length of the adjacent side. So I have my tangent of 18.43 degrees equals 18.46 over F. I put this over 1 so that I can cross multiply and divide. So 18.46 divided by the tangent of 18.43 degrees, giving me 55.40. Back up here, that makes this 55.40 millimeters, which means down here, this piece is 55.40 millimeters. This piece over here, we already know, is just the radius of the circle of 30 millimeters. So my distance x is just found by adding those three pieces together. 30 plus 9.48 plus 55.40 adds up to be 94.88 millimeters. So x is 94.88 millimeters. The area here is not so bad at this point. We have three shapes that are actually quite simple. We have the rectangle here that's 55.40 by 10. Which is 554.0 millimeters squared. We have this triangle, which is 9.48 by 28.46. First divided by 2 gives us 134.90. We have this triangle here, which is 18.46 by 55.40. First divided by 2 because it's a triangle. was 511.34. And our final piece is this sector of a circle over here. Well, it has a radius of 30 millimeters, and we know that this angle here is the supplement of this one here. That angle would be this angle down here, which is actually 71.57, just the complement of this other 18.43. So that area is going to be pi 3.14 times my 30 millimeters squared, would be the area of the whole circle, times, well, 180 minus 71.57 is 108.43. So 108.43 out of 360. US 851.18 millimeters squared. And so we add those four areas together to get our total area. We're saying I'm getting 2051.42 millimeters squared. So good stuff. Okay, so hopefully you guys, I haven't had time to check Blackboard. I kind of stayed away over the weekend. See who's got your tests submitted. I will work on grading those this afternoon, and if what I don't finish up, I will get done tomorrow morning. So your unit tests will get graded. If you don't have those submitted, make sure you get those in soon. That's gonna a big chunk out of your grade so far, and we do only have about 5.5 weeks left here. For now, your homework, there's a worksheet attached in Blackboard. It actually has two problems, very similar to the ones we just did. For the next several classes, by the way, for about the next 2 weeks at least, we're going to be working on worksheets that I'll have posted in Blackboard. It would be a good idea to get those, to have those printed off ahead of time and have them with you. I will try to have copies printed for when I'm in class, but for the Tuesdays and Thursdays where I'm not there, it wouldn't be bad to have them printed. Otherwise, if you don't have printing capabilities, make sure you remind me tomorrow, talk to me, and I'll make sure I get copies made, and I'll hand them out to you ahead of time. I'll get them handed out to you at some point so that you can have those copies ahead of time at least. And I'll let you know the date that we're going to use them when I hand them out so you have them available. But we will be working out of several copies printed off of worksheets from Blackboard for the next 2 weeks.